It's good afternoon, one and all. I am Lieutenant G. Somasundara Ori, behalf of Postgraduate and Research Department of Mathematics, DWARAKA Das Govardhan Das VAISHNAV College. I welcome our Honorable Secretary, Shri Ashok Kumar Mundraji, and our beloved Principal, Dr. S. Santosh Babu, and Convener and Head, Department of Mathematics, and this webinar, R. Venkat Ramanan, and all our professors, senior staffs, and my colleagues, and my dear students for this webinar. The national webinar on fuzzy sets and their applications. We start this webinar with the prayer.
சீராரும் வதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
I have a great pleasure to introduce today's resource person, Dr. B. Abhirami, currently working as Assistant Professor of Mathematics in Postgraduate and Research Department of Mathematics, DWARAKA Das Govardhan Das VAISHNAV College. She has 20 years of teaching experience and completed her master's degree from University of Madras and a MPhil from Madurai Kamaraj University and her doctorate from Manonmaniam Sundarnar University. Her area of interest is fuzzy sets and its application. She published 8 research papers in various international journals and participated 8 international and national level seminars, symposiums and workshops. She currently guiding a student pursuing MPhil degree in fuzzy sets and its application. She already completed 5 MPhil students and also taking various positions in college committees and mainly is taking the non-major elective coordinator for the Shift 2 course DG Vaishnava College. Now I welcome you, ma'am. Now session is yours.
Thank you, sir. My sincere thanks to our Secretary, Shri Ashok Kumar Mundraji, Principal, Dr. S. Santosh Babu, Professor R. Venkat Ramanan, Head, Postgraduate and Research Department of Mathematics, DWARAKA Govardhan Vaishnav College, for giving me this opportunity to take part of this national webinar series 1. My pranams to all my gurus. The blessings. I will start my talk on fuzzy sets and their applications. So first, we should know about the classical set. So classical set, as everyone knows, classical set is a collection of distinct objects. So for example, here, the set of students passing grades. So each individual entity in this, each individual students, we call as a member or element of the set. So the classical set is divided into two groups, members and non-members. That is, the students belongs to the member of the set, passing grades. Non-members other than that. So in classical set, no partial membership exists. So for a given set A, the elements of A1, A2, A3, etc., An, that A can be represented for elements x belongs to X by its characteristic function. Membership mu A of X is equal to 1 if X belongs to X, 0 otherwise. It means the set, the member, each individual entity is a member. Then we can say that the membership function mu A of X is 1. If they are not the member, then it becomes 0. So here there are two conditions, zeros and 1. Either member or it is a non-member. Fuzzy. So the word fuzzy means vagueness, ambiguity. So our human systems and their activities are not certain, they are not clear, but they have a certain degree level, the tolerance level. So we have to set a degree, if it is not clear situations, we have to set a degree or tolerance level. That level should be studied and analyzed by a system with varying degrees. That is, we have to set a degree tolerance level. So for varying the degrees, for not clear system should be set right, should be fixed by the degree or tolerance level. That degree, the varying degree, will be analyzed by using of fuzzy. The first attempt was made by Professor L.A. Zade. He formulated a system in which sets are represented by membership functions in the year 1965. So we want to set a degree level of varying degrees that should be represented by a membership function. So such systems are called fuzzy sets and systems. So after introducing the fuzzy sets and systems, many researchers start doing in pure and applied mathematics, being reformulated in terms of fuzzy sets. So classical set into fuzzy sets. The word fuzzy means vagueness, ambiguity. So which are not clear or vague. We have to set the tolerance level. It is grade of the membership we have to fix. In classical set, either yes or no. The membership function is, the grade of the membership function is fixed 1 or 0. So between 0 to 1, it is not analyzed. So fuzzy is analyzed between zeros and ones. In the real world, many times we encounter situations. That is, we are facing many situations. We can't determine the state is true or false. There is some confusion. There is a fuzzy. So the fuzzy logic provides a very valuable flexibility for reasoning this. So in this way, we can consider the inaccuracies and uncertainties of any situations. For example, so words like young, tall, good, or high are fuzzy because we can't determine which factor we can say that it is young. They are young. Which factor we can say they are tall. So we cannot judge the person who is young, tall, good, or high. According to our perceptions, we are saying that the person is young, tall, good, or high. So these are fuzzy situations. So there is no single quantity value which defines the term young. For example, some people age 25 is young, and for others, age 35 is young. Here, the concept young has no clean boundary. So there is a no grade of this membership function. As I told earlier, no grade for fixing the young in classical set, either young or old. But here we have encountered the situations, we are analyzing the situations, and we are setting the boundary level. Age 35 has some possibility of being young, and usually depends upon the context. That is, as per the perceptions, it defines. For example, we have three individuals A, B, C, aged as 10, 40, and 70 years old. He asked an individual D of 90 years about the old age or youth. He would say, among the ABC, he would say, all are young. But if he asks another person of 30 years old, he will reply, would be B and C are old. So there is no clean boundary for the concept of young. So fuzzy encounters this situation. Fuzzy set theory is an extension of classical set theory. Yes. Elements have varying degree of membership. So in classical set theory, we have the degree of membership function as 0 and 1. Whereas in fuzzy set theory, we are going to see between the intervals 0 and 1. A logic based on two truth values, true and false. So it is in a human reasoning, it is insufficient data whether the state is true and false. So fuzzy logic uses the whole interval between 0 and 1, false and true, so to describe the human reasoning. A fuzzy set is any set that allows its members to have different degree of membership or membership function having interval 0 and 1. Between 0 and 1, the 0 and 1, we are setting the different levels of degrees we are going to set for each and every members. We are going to set a different degree that we called as a membership function. Fuzzy logic. Is it cold? If I ask, is it cold? Normally we used to say yes or no. But whereas in fuzzy, we are saying that you can say very much, little, and very less. There are three possibilities. So very much, we are setting the grade as 0.9, little 0.5, and very less 0.1. So that is the difference. Is water colorless? In this, we are saying yes and no. Is wrong honest? In fuzzy, we say that extremely honest, very honest, honest at time, extremely dishonest. So here, extremely honest, very honest, honest at time, extremely dishonest, or fuzzy. In brackets, we are mentioning that the level of membership function, the degree of the membership function is measured in the brackets. So the extremely honest, if he attains 1, you can say that he is extremely honest. 0.80 is very honest. 0.40, honest at time. And 0, extremely dishonest. So likewise, we are assigning the fuzzy variables into membership functions to get a optimal results. In real world, there exists much fuzzy knowledge, as vague, uncertain, inexact, etc. Human thinking and reasoning frequently involve fuzzy informations. Human can give satisfactory answers which are probably true. So they are saying yes or no, such type of answers, but which are probably true or maybe false. So our systems are unable to answer many questions because the systems are designed based upon classical set theory. Because we are setting the unreliable and we are having incomplete informations, and also we are having that yes or no conditions. We want our system should be able to cope with unreliable and incomplete information. So fuzzy system have been provided solution for this fuzzy set. So like a classical set, so there we have a membership function. If it is yes, 0. If it is 1, true. 0 as false and 1 as true. Here, fuzzy set. A fuzzy set can be defined by assigning to each possible individual in the universe of discourse a value of representing its grade of membership function in the fuzzy set. The membership function of a fuzzy set, so the fuzzy set can be represented as A tilde symbol, if we call it as a fuzzy A, is denoted by mu fuzzy A. That is, mu fuzzy A is mapping of x tends to close interval 0. The function mu fuzzy A, is called the membership function, and the set fuzzy A is x comma mu fuzzy A of x such that x belongs to x. So x is a member of the set. We are assigning the member, the degree for this member as mu A of x, defined by the fuzzy number, that is the degree of the membership function is within the interval 0 and 1. For each x belongs to fuzzy A, which is subset of x, is called a fuzzy set. So we will discuss with an example. Let x is equal to G1, G2, G3, G4, and G5 be the reference set of students. So students reference set. So here fuzzy A, here we are decide that the fuzzy set is smart. So we are finding the smart students. So smart is a fuzzy term. So for smartness, we are finding the smartness for each and every student by assigning the degree of the function. So here the fuzzy smartness indicates that G1 is assigned to 0.4. The level of 0.4 attains the person's G1 smartness is assessed. For 0.5, G2 smartness is assessed. For 1, G3 smartness is assessed. So like this, we are framing the degree for each member of the set. So after framing the membership functions, we should frame the fuzzy numbers. So fuzzy numbers, so there are some following properties to frame a fuzzy number. A fuzzy number is a quantity whose values are imprecise rather than exact, as in the case with the crisp numbers. So a real fuzzy number A is described as any fuzzy subset of the real line with membership function mu A of x possessing the following properties. Here there are conditions. Mu fuzzy A of x is a continuous function from the real line to the closed interval 0 and 1. And second condition is mu fuzzy A of x is equal to 0 for all x belongs to open interval minus infinity comma a union open interval d comma infinity. It means that less than a it attains 0. If it is greater than b, mu fuzzy A of x is 0. Mu fuzzy A of x is strictly increasing on closed at a, open at b. Mu fuzzy A of x is equal to 1. It is the height of the membership function for all x belongs to closed interval b and c. Mu fuzzy A of x is strictly decreasing open at c, closed at d, where a, b, c, d are real numbers. So this is the framing of fuzzy numbers. So triangular fuzzy number, we call it as a triplet, A, B, C. So according to the definition of fuzzy number, the properties of fuzzy number, we are framing a fuzzy number. A fuzzy number, fuzzy A equal to ABC, is said to be triangular fuzzy number, with the membership function is mu fuzzy A of x is equal to x minus a divided by b minus a less than or equal to x less than b, x minus c divided by b minus c, b less than or equal to x less than or equal to c. There are 0 otherwise. So I will explain in the graphical representation. If it is a less than a, it attains 0. When it is between a and b, we have to use the left membership function x minus a divided by b minus a. When b to c, we are assigning the right membership function. This b is a right membership function. B is the center of the 1. It attains the value 1. Nearest to 1. So x minus c, b to c has a right membership function x minus c divided by b minus c. So a, b, c, where a and c are the lower and upper bounds, b is mostly likely value of a. This 1. Membership value attains its 1. So it is a different way. There is a A1, A2, A3. So same, we can represent in a different variables A1, A2, A3. So A1, A3 lower and upper bounds, and A2 is the attains 1. Here, if I choose the x value, this is the x value, this is a membership function, the graded of the membership function, mu a of x, member of the set, that is should be graded here. So the height of the membership function is 1, here 0 to 1. So if I choose the x value between A1 and A2, so we have to apply the left membership function. If the value of x lies between A2 and A3, I have to apply the right membership function. So next is now it is moved to trapezoidal fuzzy number. A fuzzy number, fuzzy A, B, C, D is said to be a trapezoidal fuzzy number if its membership function is given by mu fuzzy A of x. The membership function is defined as 0. X belongs to open interval minus infinity comma A union open interval t comma infinity. That is less than A, it attains 0, and greater than t, it attains 0. The left membership function is x minus A divided by b minus A. So the range is closed at A and open at B. It is 1, it attains the height of the membership function between B and C, between B closed at B and closed at C. So closed interval B and C. The right membership function is x minus D divided by C minus D, open at C, closed at D. So you see in a graphical representation. So A, B, C, D are the triangle fuzzy number. So this fuzzy number, trapezoidal fuzzy number and triangular fuzzy number, we have to frame according to the properties of fuzzy number. So according to the properties, we have to frame a fuzzy number. So A, B, C, D are the trapezoidal fuzzy numbers. So here the x is a members of the set, and mu A of x is a membership function. So the height of the membership function is 0 and 1. For example, if you want to find a value for x is equal to 4. Here I consider as A is 2 and B is 6, C is 9 and D is 12. For the value x is equal to 4, I want to find a value for 4. Mu fuzzy A of x of 4 is, and this 4 lies in the left membership function. So I can apply the formula x minus A by b minus A. I got the value as 0.5. The value of x is equal to 10 is in a right membership function. So then I apply the x minus g, c divided by c minus g. I got as 0.666. So this is the right membership value. For the x is equal to 10, we got the membership value as 0.67. Next, it should be extended to generalized one. So we already discussed membership function. Now it goes to generalized membership function. The membership function of the fuzzy number A is mu fuzzy A of x. Here left membership function is closed at A and open at B, and W is the height of the membership function closed at B and closed at C. That is a closed interval BC. The height of the membership function is W. This W, it's not fixed to 1. If it is fixed to 1, it is a membership function. The height of the membership function is 1. The ordinate trapezoidal fuzzy number. Here, trapezoidal 1 membership function, that is 0 less than equal to W less than equal to 1. The height of the membership function is between 0 and 1. We can choose any of the heights. See here the membership function is 0 and 1. So here the height of the membership function is 1. But in generalized, we can have any heights between 0 and 1. We can choose any of the height as a height of the membership function. We can fix the height of the membership function. So the right membership function open at C and closed at D, greater than D becomes 0, and less than A it becomes 0 otherwise. So the greater than D becomes 0, the way mentioning as otherwise. Here where 0 less than W less than equal to 1 is a constant. So we are fixing the height of the membership function between open at 0 and closed at 1. So it's not necessary the height of the membership function is 1. Here we can choose any number of heights. A, B, C, D are real numbers, and left membership function maps to closed interval AB to closed interval 0, W, and right membership function is closed interval Z, D tends to closed interval 0, W. Now we will see that generalized fuzzy number. So for framing a generalized fuzzy number, the following properties are was. A real fuzzy number, fuzzy A, is described as any fuzzy subset of the real line with a membership function mu fuzzy A of x possessing the following properties. So first one, the membership function is a continuous function from real line R to the closed interval 0, W. W, I told you, it's the height of the membership function. Membership function is 0 equal to 0 for all x belongs to minus infinity comma a, open interval minus infinity comma a, union open interval t comma infinity. So it attains 0, it is an open interval minus infinity. It means that less than a, it attains 0. Membership function of x is strictly increasing on closed at a and open at b. Mu fuzzy of x is equal to w, the height of the membership function, attains for all x belongs to closed interval b and c, bc. Mu fuzzy of x is strictly decreasing on open at c and closed at d, where a, b, c, d are real numbers. So we can frame a generalized fuzzy number according to the possessing the following properties. So we go for generalized trapezoid fuzzy number. So if the membership function mu fuzzy a of x is piecewise linear, then fuzzy a is said to be a generalized trapezoid fuzzy number. The membership function is defined as the left membership function is closed at a and open at b. W is equal W is in the height of the membership function lies in the closed interval b, c, and right membership function, the right membership function open at c and closed at d, 0 otherwise. So the left membership function is defined here w times of x minus a divided by b minus a, and the right membership function is defined as w of x minus g divided by c minus g. If w equal to 1, if it attains the height of the membership function is 1, then we can say that it is a normal trapezoidal fuzzy number. If it is between 0 and 1, then I can say it is a non-normal trapezoidal fuzzy number. So either I can use A, B, C, D to understand that it is a trapezoid fuzzy number. The height of the membership function is between 0 and 1, we can say that it is a non-normal trapezoidal fuzzy number. The image of A, B, C, fuzzy A, the members are A, B, C, D. The height of the membership function is W is given by minus of fuzzy A, images minus G, minus B, C, minus B, minus A. The height of the membership function is W. Next is another membership functions, L of fuzzy number. L of fuzzy number, a fuzzy number A is Mn alpha beta LR. LR is left and right membership function. The shape of the membership function is defined here. So left shape and right shape is said to be LR fuzzy number. If mu A fuzzy of x, that is the membership function, is defined as the left membership function for x less than or equal to n, alpha is greater than 0. Right membership function for x greater than or equal to n and beta greater than 0. Otherwise, it becomes 0. So the left membership function and right membership function is defined. So our m and alpha, beta are reals and non-negative parameters, and LR are shape functions. So this LR fuzzy number is proposed by Dubos D. Reid in 1980. He proposed this one LR fuzzy number. So we have different types of membership functions. So which gets LR fuzzy number, in a trapezoidal number, triangular number, we will get the accuracy of the result is keep on accurate. So in LR fuzzy number, we are going to discuss about the shape of the membership function. It should not, it is not necessary to have the triangular or trapezoid. You have any type of shapes in the membership functions. That is LR fuzzy number. Here, the m and n is the membership values, and alpha and beta are the width of the left region and beta is the right region, width of the right region. So we can have any number of shapes. The LR fuzzy numbers gives the different types of shapes of the membership functions we can attain using a Euler fuzzy number. Here, the width of the fuzzy number alpha and beta, we can have the points m minus alpha, m, n plus beta. These are the members of the set, members of the set m minus alpha, m, n plus beta. If alpha equal to beta, then I can say that it is a symmetrical shape. So m minus alpha, m, n. So m and are the membership values. The alpha is the width of the left region and width of the right region. So we can use m minus alpha. Suppose if we have the value m, then we can say values of m, n, alpha, beta is given. You can easily find the points for this shape of the left one and shape of the right one, and the width is fixed. Because of the width is fixed, then we can easily frame the left shape as well as the right shape. So this is a Euler fuzzy number, and we have a this is m minus alpha. This is a Euler fuzzy number. So alpha is the width of the left region and beta is the width of the right region. So we can have any number of the shape functions. It is a linear, exponential, power, and rational. So we can choose left membership as a linear and right membership as a rational. So we can take exponential. So we can have different shape of the membership function exist. So depends upon the situation, the situation of the problem, we can frame a different types of membership functions. So this is the left shape and the right shape based on the alpha and beta. So if alpha and beta, then I can say that it is a symmetrical shape. So f is a shape function if it satisfies the following conditions. F is a continuous, non-increasing function, and the offline closed interval 0 and open at infinity. F of 0 is with 1 and f is strictly decreasing on this part of the domain on which it is positive. The following functions are examples of shape functions. We can use these shapes depending upon the situation of the problem. So linear, exponential, power, and rational. So after framing the fuzzy numbers, whether it is a triangle or trapezoidal or Euler shape or symmetrical, so any number of shapes we have to calculate by using of the arithmetic operations to find the optimal result. Here the two fuzzy numbers A1, fuzzy A1, the numbers are A1, B1, C1, D1, and fuzzy A2, A2, B2, C2, D2, B2, trapezoidal fuzzy numbers. They has the addition operation. D1 plus D. So it is a fuzzy like this. And we have a multiplication operations. So A, B, C, D, we can easily determine A, the minimum value of this product, and B, the minimum value of the product of these two elements, and C, the maximum value of product of two elements, and D, maximum of product of two elements. And lambda fuzzy A, the scalar multiplication of fuzzy number. If it is lambda greater than 0, we have the arrangement like this: lambda A1, lambda B1, lambda C1, and lambda D1. If it is lambda B1 and lambda A1. So these are the arithmetic to calculate the A, B, C, D. Fuzzy A is equal to A, B, C, D is said to be a non-negative trapezoidal fuzzy number if only if A greater than or equal to 0. If it is a value is positive, then we get a positive one positive fuzzy number. We call it as a non-negative trapezoidal fuzzy number. And 0 trapezoidal fuzzy number, all the values, the members of the elements are 0, then I can say that it is a 0 trapezoidal fuzzy number. If the members are equal to fuzzy numbers, in two fuzzy numbers, the members of the two fuzzy sets are equal, then I can say that equal trapezoidal fuzzy number. Okay. First, we frame the membership function, fuzzy number, and the arithmetic operation. Next, we go. So in this case, we are framing that ABCD is a trapezoid fuzzy number. So the two trapezoid fuzzy number, I want to find which one is a greater one, which one is a lesser one. So here, in two fuzzy numbers, so I want to find that A1 is greater than A, if A1 is greater than A2 or A2 is greater than A1. That I have to calculate by using of the ordering of fuzzy numbers. To compare the fuzzy numbers, it is ordering the fuzzy numbers. The ranking function is an important tool for ordering the or comparing the fuzzy numbers. So in the literature, different types of ranking functions are used. Chen SH, Chen CH, 4 times fuzzy numbers. In order to rank fuzzy quantities, each fuzzy quantities is converted into a real number. So that is very important. So if you want to rank the fuzzy quantities, the fuzzy quantity is converted to a real number. Then only we can compare which one is greater, which one is lower. So fuzzy quantity is converted into a real number and compared by defining. So we have to compare. How we are comparing by defining a ranking function. The ranking function map to set of fuzzy numbers to set of real numbers. So which assigns a real number to each fuzzy number. So if we take a fuzzy number, for instance, if we take this fuzzy number, we have to convert by using of ranking function. We have to convert this fuzzy number into a crisp number and real number. We are comparing the A1 as well as A2. If the number is greater than A2, then I can say that the fuzzy number of A1 is greater than fuzzy number of A2. So this is the very important one that assigns a real number to each fuzzy number where a natural order exists. So we are assigning the real number to each fuzzy number by using of ranking function, and we are comparing the results, and that results exist to find out which one is greater and which one is less smaller. The ranking function. So ranking function is a function, the fuzzy R. It is a ranking function. R maps to fuzzy R tends to R. The f of R is set of fuzzy numbers defined on set of real numbers, which maps each fuzzy number into the real line. So ranking of fuzzy number by Agar proposed a procedure for ordering fuzzy sets in which a ranking index R of fuzzy A for any parameter represented by a fuzzy number. So this fuzzy A is of LR shape function, Mn alpha beta. Alpha beta is the width of the left region as well as the right region. And L of x and R of x membership function is here. We are taken as a linear one, maximum 0, 1 by x. So for this linear LR shape function, we have the rank function is 1 by 2 of m plus n minus alpha by 2 plus beta by 2. So the LR shape function, we propose the ranking function. And Leo TS and Wang MJ proposed in 1922. A ranking function is a function R mapping f of R to tends to R, where f of R is set of fuzzy numbers is defined on set of real numbers, which maps each fuzzy number into the real line. So the fuzzy A, Mn, alpha, beta, be a trapezoid fuzzy number. Then he proposed for trapezoid fuzzy number, the ranking of A is 1 by 2 m plus n plus 1 by 4 beta minus alpha. So these are the basic things required to frame a problem, to formulate a problem, to produce a optimal results. So applications for fuzzy transportation. So in a classical transportation model is to transport the goods from one various sources to destinations. Here the sources and destinations are fixed in a classical transportation model. It is single homogeneous commodity which are initially stored at various origins to different destination in such a way that total transportation cost is minimum. So source to destination. So we are assuming that the total transportation cost should be minimum. The standard transportation model assumes that the direct route between a source and a destination is a minimum cost route. Source is fixed, destination is fixed, transportation is also fixed. We can say that it is a cost, minimum cost route. In real life problems, we cannot have the minimum cost in advance. So here it is a fuzzy, right? For the uncertainty, variables of transportation model may vary in a frame. For example, shipping costs may be uncertain with the change of weather, shipping ways, condition of shipping ways, conveyance, and the existing risk. Sometimes when it is on transportation, the vehicle may got broke, getting a problem during the transportation. So that kind of inconvenience will exist in the classical transportation problem, but that one will not take account. They are fixed, source are fixed, and destination is fixed. The transportation is minimum cost. So this uncertain information will make decision makers puzzled. So so we are not counting the conveyance. We are not taking account of shipping ways, whether we have the vehicle getting problem or not. So this kind of uncertain informations will not take account in a classical transportation problem. So here it is a puzzle. What is a fuzzy existing in this type of model? So decision maker is sure about the precise values of transportation cost, availability, and demand of the product. So it should be fixed. Cost is fixed, availability and demand is fixed. So according to the decision maker. For the classical transportation issues, factors affecting shipping cost not considered, weather, etc. etc. A lot of factors are affecting the train during the transportation. The solution, fuzziness is needed in this situation. It is a difficult task to find the best transportation investment project. In this case, uncertain factors are considered as fuzzy numbers and make it as a constraints and frame as a fuzzy linear programming model. And then we have to convert everything into a transportation model, and we are applying the ranking method. If you are using a LR shape function, then you have to use the suitable ranking method. If it is a trapezoid fuzzy number, you have to apply the ranking method. If it is a generalized trapezoid fuzzy number, you have to apply the generalized ranking function to get optimum and minimum transportation cost. So application of fuzzy logic in design of smart washing machine. So washing machine is of great domestic necessity as it frees us from the burden of washing our clothes and saves a lot of time. So in regular washing machine, we have only start and stop mechanism. In addition to its starting and stopping issues, the mechanical timers are not efficient with respect of maintenance and electricity usage. So it is in a regular washing machine. So recent developments have shown that merger of digital electronics in optimal functionality of this machine is possible. So that we call it as a smart washing machine. So we are having the merger of digital electronics to make the function optimal. So we are now using the smart washing machine. So fuzzy logic controller based washing machine, which is capable of automating the inputs and getting the desired output. So in the fuzzy logic control for smart washing machine. So fuzzy logic controller based washing machine, we are using that we call it as a smart washing machine. Here, the type of clothes. So in smart washing machine, it has a menu. It is a type of clothes, type of detergent, type of stain, temperature of washing factor, washing water, other factors. It is the other factors. We have that the weight of clothes and water, amount of water soap, and after wash water drainage, spin time requirement, remove the soap water and heat required to dry the wash cloth. So these are the things, these are the mechanisms available in smart washing machine. The practical model implementation. So we are taking that washing machine with the two inputs, saturation time and dirtiness, and one output as wash time. So dirtiness, removing the stain, saturation time. So these are the two inputs and one output we consider as a wash time. For practical purpose, type and amount of detergent has been kept manual. So here, the dirtiness and saturation, two inputs. So dirtiness and saturation time, it is a removal of stain. And after this both inputs, after the mechanism, we'll get the washing, of course, output is the clean clothes. This is the mechanism inside in the washing machine, smart washing machine. So dirtiness is measured in the membership function. So here they are mentioning in a triangular and also trapezoidal, but it's not necessary to be a triangle or trapezoidal. It can have any number of shapes. So according to that, we have to apply the ranking functions and we have to get the optimal results. So here, low, the range is fixed as 0 to 30 and here defines a fuzzy subsets as low, medium and high. We call this as a linguistic variables, low, medium and high. For example, in the range 15, exactly in the middle, the high of the dirtiest high is 0 and low is also 0, but medium subset is 0.9, which means all the three will execute in result extraction to 0, 0, 0.99 and 0 levels. This is a dirtiness according to the input levels and the mechanisms. We are setting the different ranges. We are representing everything in a membership functions. Saturation time, the cleaning of the stain. The saturation time is defined in the range 0 to 10 minutes. So they are fixing the 0 to 10 minutes. In between 0 to 10 minutes, they are classified into three levels, low, medium, and high. So this is the saturation time. This is also represented in a membership functions, 0 to 10 minutes, and this where the membership function is given as 0 to 1. And the wash time is defined in the range from 0 to 15 minutes. So this is the X values and this is the membership values. Based on the classification of above mentioned input, saturation time and dirtiness, so that process can be done, and after that we are having the 5 sublevels. So for washing time, the output is defined by the fuzzy subset as very low, low, medium, high and very high. So in low, we have the time is 0 to 7 and medium 4 to 11 minutes and high is 7 to 11 minutes and very high we have 0 to 15 minutes. So this is a membership function, the output of wash time. The complete input and output parameters are given here. Saturation time and dirtiness is the wash time. If the dirtiness is low and saturation time is small, then the wash time is very low. If it is a medium dirtiness and medium saturation time, it has a medium wash time. So dirtiness is low and saturation time is medium, then wash time is low. So this is the output of fuzzy low. Using the fuzzy logic, we are ranging this wash time. This is the output of the wash time. So we are having the different types of linguistic variables. So they have the range is given, the wash time range is given. So here the very low the range of washing time is 0 to 4 and low is 0 to 8 and medium is 4 to 11 and high is 7 to 15 minutes to wash and very high is 11 and 15. So here the sublevels in linguistic variable, we are choosing the fuzzy value, one on very low, low, medium, high and very high. So it contains both, the output is having the washing time output that can be represented in the membership function. So watch time. So this is the membership function, the output result is shown here. So very low it is 0 to 4 and low is 0 to 8. So these are 8 minutes to 0 to 8 minutes to, if it is a low dirt and the stain saturation time and dirty time, dirtiness to clean the clothes. If it is a low, the range of minutes to clean the clothes is 8 minutes, 0 to 8 minutes. And we have the further scope of research or interest to read fuzzy. Fuzzy neural network, intuitions, fuzzy sets, fuzzy graph, fuzzy algebra, fuzzy real analysis, and fuzzy complex. Not limited to, there are fuzzy topology. So a lot of work is going on, but we need the application oriented, real time applications to give the optimal result for our society. That is very important. So that fuzzy sets and system needs that one. So we need the real time application of problems. We solve that and we have to produce the optimal result for our society. That applications we require for further research. So these are the references I used to frame a PowerPoint. These are the references. And if there is any questions, you can ask me. Is there any questions?
Dear audience, if you have any questions, please put in a text box, chat box. Please you text it in a chat box if anybody having any questions. As a participants and viewers, if you have any questions, yes, kindly put in a chat box. Waiting. Dear participant, if you have any questions, any doubts, just kindly text it in a chat box. So thank you, ma'am. There's no questions in chat box, ma'am.
I thank all participants who joined in this national webinar. Thank you.
As I'm very glad to propose the formal vote of thanks. First, I thank our college secretary, Shri Ashok Kumar Mundraji, and our beloved principal, Dr. A. Santosh Babu, and our convener and head, or Venkat Ramanan, and our department faculty members, my colleagues, and the technical team, and the students. Thank you very much for your attentive listening. Ma'am has covered what is classical set to fuzzy set and all the applications of fuzzy sets. And then finally is given what is the scope, the fuzzy algebra, fuzzy graph, fuzzy network analysis, and fuzzy complex and everything. So it's a great scope on this one. So yesterday we had a graph theory. Today we have the fuzzy sets. These two areas are the very actively is doing research in Chennai and other south part in Tamil Nadu. So it's very famous and very interesting topics. It's a very good, ma'am. Thank you, one and all. Thank you, ma'am. Then
Thank
say
you,
with the
sir.
announcement for tomorrow we have at 2 o'clock have that webinar Introduction to Geometric Function Theory by Dr. S.P. Vijayalakshmi, Assistant Professor, PG and Research Department of Mathematics at DG Vaishnava College, Chennai. Now we post the feedback link in a chat box. Then kindly you fill it your feedback. So thank you one and all. Your feedback link will be posted in chat box.